Alright, let's look at the Hallmark 3.1, problem number 8. Right, so we want to know where the normal line to the parabola y equals x minus x squared at the point 1, 0 intersect the parabola again. Alright, so let's do that. Alright, so we need to find the equation of the normal line. So if you take the derivative, so y prime, alright, so that would be derivative of x is 1, and derivative of negative x squared would be negative 2x, right? Then we can find the slope of the tangent line by plugging in x equals 1, right, which is going to be 1 minus 2 times 1, which is negative 1, right? So this is the slope of the tangent line. So if you want to find the slope of the a normal line, would be we have to take the negative reciprocal, right? So it's a negative reciprocal of negative 1 would be 1, right? Slope is 1, right? So the equation of the tangent line is going to be, we know that this is going to be x1 and here is y1, right? So the normal line, normal line has this equation, y minus y1, which is 0, is equal to, slope is 1, times x minus x1 is 1, right? So this is just going to be y equals x minus 1, right? Then we just have to find the intersection between these two guys. So we can just set this guy and that guy equal to each other. Right? So let's do that. So we have x minus 1 is equal to x minus x squared. Right? So it looks like we have we can cancel x here and x there. Alright, then looks like we can just multiply both sides by negative 1. That way we get 1 is equal to x squared. Then we can just take the square root of both sides. So it's going to be a plus or minus 1 is equal to x. Alright. Alright, so we have two numbers, plus 1 and negative 1. Remember that plus 1 is this point right here. Right? So we have to take the other one, so it's going to be x is equal to negative 1. Right? So we have x equals negative 1. Then you can use either equation. You can use the parabola or you can use the line and plug in the x value back in, so we can get the y value to be negative 1 minus 1. So I'm just using the equation of the normal line, so that would be negative 2. Right? So x is negative 1 and the y is negative 2. Right? Let's type it in. Right? So we have a negative 1 comma negative 2. Right? So that's the point. And then if you want to find the picture, right? So let's look at these pictures, right? First, we have parabola, right? The leading coefficient is negative, so parabola should be facing down. So you can see that the first one is good, second one is not good, the third one's good, fourth one is, so it's going to be first one or the third one, right? Then so we look at the x equal 1, 0. So you have 1, 0. You have a tangent line and a normal line. That looks good. And this guy also looks good. And the only difference is it seems like we have a different kind of parabola here. All right, let's see which is more reasonable. Alright, so x-intercept for this guy is going to be, if you factor out x, so this is x times 1 minus x. So x-intercept is 0 and 1. Yeah, you have 0 and 1. So number 1 looks good right here. Number 3, it does not go through 0, so this cannot be it. So we know that the correct picture is this guy. All right, let's see what else. All right, so that's that. All right, let's submit for testing. All right, it came back and looks like we got the point correctly, and we have the correct picture as well. All right, that's it. I hope that this was clear.